Hello friends, subscribe my YouTube channel Allpedia Information and press the bell icon to never miss any updates from us. In physics, sound is a vibration that typically propagates as an audible wave of pressure through a transmission medium such as a gas, liquid or solid. In human physiology and psychology, sound is the reception of such waves and their perception by the brain. Humans can hear sound waves with frequencies between about 20 Hz and 20 Hz. Sound above 20 Hz is ultrasound and below 20 Hz is infrasound. Different animal species have varying hearing ranges. Sound can propagate through a medium such as air, water and solids as longitudinal waves and also as a transverse wave in solids. See longitudinal and transverse waves below. The sound waves are generated by a sound source, such as the vibrating diaphragm of a stereo speaker. The sound source creates vibrations in the surrounding medium. As the source continues to vibrate the medium, the vibrations propagate away from the source at the speed of sound, thus forming the sound wave. At a fixed distance from the source, the pressure, velocity, and displacement of the medium vary in time. At an instant in time, the pressure, velocity, and displacement vary in space. Note that the particles of the medium do not travel with the sound wave. This is intuitively obvious for a solid, and the same is true for liquids and gases. That is, the vibrations of particles in the gas or liquid transport the vibrations, while the average position of the particles over time does not change. During propagation, waves can be reflected, refracted, or attenuated by the medium. Sound is transmitted through gases, plasma, and liquids as longitudinal waves, also called compression waves. It requires a medium to propagate. Through solids, however, it can be transmitted as both longitudinal waves and transverse waves. Longitudinal sound waves are waves of alternating pressure deviations from the equilibrium pressure, causing local regions of compression and rarefaction, while transverse waves in solids are waves of alternating shear stress at right angle to the direction of propagation. Sound waves may be viewed using parabolic mirrors and objects that produce sound. The energy carried by an oscillating sound wave converts back and forth between the potential energy of the extra compression in case of longitudinal waves or lateral displacement strain in case of transverse waves of the matter, and the kinetic energy of the displacement velocity of particles of the medium. The speed of sound depends on the medium the waves pass through and is a fundamental property of the material. The first significant effort towards measurement of the speed of sound was made by Isaac Newton. He believed the speed of sound in a particular substance was equal to the square root of the pressure acting on it divided by its density.